tell us what we're seeing here.
So here we are out in Bay Jimmy, which is on the northern part of Barataria Bay. And a lot of oil accumulated out here in Bay Jimmy. It came up through the passes. There are some passes that are due south, passes being the term down here for tidal inlets. The oil came through the passes and probably got washed ashore on the edge of these marshes under the influence of southerly winds. So what you see out there is you see some areas that were impacted by oil. That impact area used to be much darker. You can still see some of that dark spot stuff in there is most likely still oil that's remaining. And one thing that's worth noting is you can see that brown area where roughly where the oil was. And I think that's one interesting point about how the marsh works and how the oil interacted with the marsh. A lot of the oil stayed in the top, let's say, 5 to 10 meters of the marsh front. It varied a little bit from place to place. Okay, so over there you can see where the oil is and has been. Some of the darker spots over there are most likely still oil. You can see that the oil stayed in the front, let's say 5 to 10 yards of the marsh. This is something that seems to have been something of a widespread pattern. We've often talked about marshes as good traps and good filters, and this is probably the best example I've seen of it, is that the marsh grass has trapped much of the oil in the front 5 to 10 yards. One thing that you can see is that the oil did lead to some mortality of the marsh plants. You can see what appear to be some dead marsh plants over there. The brown marsh is most likely dead. You can also see in the middle over there, you can see some new shoots coming up. And those are most likely shoots that have come up since the oiling event. So it's most likely some regrowth after the marsh, after the oiling event. And one of the ways that we think we know that that's regrowth as opposed to just stuff that didn't die is that it's much shorter than the stuff behind it. That Spartina alterniflora back there will grow very densely, and most of it should be the height of what you see of the live stuff back there. And in fact, even if there's any height gradient, the stuff that's closer to the creek is typically a little higher. That effect is greater in terms of the height differential. It's kind of a greater effect that we'll see in marshes in the high tidal range sites in the northeast, but nonetheless, typically you'll find marsh plants at the edge that are taller than marsh plants in the interior. And so the fact that we see these short shoots growing up suggests that it's growth that has occurred recently. It's more recent growth than what's behind it, those tall plants behind it. So it's almost certainly, therefore, regrowth that has occurred since the oiling event. And the basic story, I think, of what's going on is that the plant roots didn't die. One of the biggest concerns people had when this oil was when the spill was breaking, was would it kill the roots? And people asked myself and people asked other people, will everything die off? And a lot of people said it depends on what happens to the roots. If the roots die off, we could lose the marsh, and by extension, if the roots don't die off, things can regrow. So I think that what happened is the stems were killed, and there was still roots around, and so there was some root regrowth. So there was regrowth from the roots.
So you're saying that the stems that we see that are right close to the water, that's new?
Those green stems, yeah.
They died and now they've grown
right,
back.
particularly the smaller ones back there. So,
yeah, I see that.
yeah, some of those smaller ones are very much likely new growth. That little clump over there that's almost submerged, that's a higher thing. That might be a little harder to say. But those short stems, like right in the black, that's very likely regrowth.
And they're also that bright green.
And they're also that bright, yeah.
New growth. So tell me a little bit about the research that you're doing out here.
One of the things we're trying to do is we're trying to quantify this. So we are trying to do that with a series of basically digital photos. We don't want to get on the marsh because it's in a state of regrowth. It's very fragile. So we don't want to actually get out there and put out quadrats. So we've decided to set up digital cameras here and then photograph the marsh quantify the water height and the angle of the camera so we can really get a good sense of control of where we are. And then we're going to try to digitally process the photos and digitally quantify how much material is here from time to time.
Cool. How many places are you doing this?
We're going to try and do this at a couple dozen different spots.
And the places that you've selected, they have similar impact?
Yeah, we're trying to get a gradient of places that have not seen too many impacts versus places that were heavily impacted. But we're trying to get a gradient of impacts, particularly in Barataria Bay.
So what would be the effect here of any kind of diversion through Davis Pond? Has there been any freshwater here from that?
There's been some freshwater here from that, and I think we're still looking at that. I'm not fully sure what the impacts of that would be right now.
How much of the marsh, we have marsh all around us here, how much of this marsh had impacts like this?
So coast-wide, the amount of coast that was oiled was on the order of, let's say, 500 to 700 miles of coastline oiled. Those are roughly the numbers that I've seen. Here in Barataria Bay, obviously, it would be some fraction of that. This is obviously a very convoluted shoreline, so you've got, as the crow flies, you might have a much shorter distance than the actual length of shoreline. But nonetheless, if you take the amount of shoreline that was oiled and you multiply it by the length of the width that was actually oiled, you multiply several hundred miles by something that's maybe 10 yards, you only get maybe on the order of 10 square miles or less of coastline that was impacted, which is incidentally less than the amount of coastline that we lose in an average year. We lose somewhere on the order of 25 square miles of coastline in an average year, and in a bad year, much more than that. In the month surrounding Katrina and Rita, the coast lost somewhere close to 250, maybe a little less than 250 square miles worth of land. So I think that while this spill was certainly a nightmare and a disaster, it has to be put in the context of a coast that is unfortunately in a state of degradation.
So how's the oil affected the marshes that are degrading?
In terms of whether the oil will have an impact on the overall rate of marsh loss, we don't know that now. One place that I'm looking for, the U.S. Geological Survey and John Barris, who's now over with the Army Corps, has a history of making very good maps of wetland loss. They made maps of wetland loss, for the Louisiana coast for a number of years. They've done it post-incident, like, for example, post-Katrina and Rita. And I'm waiting for them to come out with their numbers, and they do a very, very good job. And so when their numbers come out, and my guess is that they would have something out in a year or so, we'll have a better sense of that.
So over the long term, do you think that, because it looks like it's kind of a patchy distribution of oil within pretty extensive marshes, and it might be that the oil doesn't have a huge effect, but it might be there would be longer term effects.
This oil spill, in terms of its impact on the coast, was very much of a patchwork. There were places that got hit very hard. There were places that got off scot-free. There are places in Barataria Bay that we were sampling in mid-July where we couldn't see any oil, and where the SCAT team, the science, the coastal monitoring teams that do coast-wide surveys, have not been able to find any oil, and those places were maybe just about 10 miles away. So it's very, very much of a patchwork, and even within here you can see the front of the marsh got hit very hard. Areas inland did not get hit so hard at all. Probably areas around this cove that are protected and more sheltered from the wind would have had much less impact. So this was what happened here was very much of a patchwork, and if there was one prediction that I would make, it's that the long-term impacts will be very much of a patchwork.
That's very reasonable. So can you describe your just describe how you're addressing this, what your research is.
Okay, sure. In terms of what we're doing, we are trying to quantify the rate of marsh regrowth. We're going to do that in a diversity of environments, areas that have been hit relatively hard versus areas that have not been hit quite so hard. And we are going to take a series of digital photographs. We're going to try and do this digitally. We don't want to actually get on the marsh because we don't want to disturb the area that we're sampling. So we're going to try and set up a digital camera, quantify our location and the camera angle very closely, and take a series of digital photographs, and then process the digital photographs and get an amount of marsh regrowth that way. So we'll have a digitally quantifiable and non-invasive method for measuring marsh regrowth.
And how often have you been out?
We've been out every few weeks since mid-July, and we're going to continue to go out and hopefully go out more extensively this month and into the fall, and then we're going to hopefully follow this up into the next growing season. So I've been collaborating with people from universities around the country, and I've tried to actually bring everyone here because, for one, this was an area that was impacted, and also I want people's results to be comparable. I want people on Team X to be able to compare their results to people on Team Y. And so I brought several teams here. Brad Rosenheim and some of his, we came here and we sampled over there some Tom Bianchi, Robert Cook, and Mike Perdue. We've got a collaborative project together, and we've been sampling the water from right here. And then people from Los Alamos National Labs, we were sampling not too far away from here. So I'm trying to get everyone to sample in this area so that we can all compare results. One thing I'll point out is that this is all Spartina alterniflora marsh. Spartina alterniflora is the dominant marsh plant. It's one of the few plants that can live in this difficult environment. This is actually a difficult environment for plants to exist in because it's salty, but the salt content changes because this is an estuary, so the salt content is variable. The water level is variable, and there's not a lot of plants that can live here. Spartina alterniflora is one of the few plants that can live in this difficult environment, and because of that, it forms almost monospecific stands. And so everything out here is Spartina, or almost everything out here is Spartina alterniflora. And actually you'll find this marsh grass from here all the way up to Massachusetts and even beyond. And so it's really the dominant marsh grass in East Coast estuaries. And so it's a very, in some ways this is a representative site of the kind of marsh plants that we might see elsewhere in Barataria Bay, and the kind of marsh plants that we might see in Mississippi and even in Massachusetts or Maine. So one thing that you can see over there is you can see some waves, small waves crashing on the marsh edge, and that wave action can lead to erosion. You can see that there's a little bit of regrowth over there, but of course there's not a lot of plants. And if there were more plants there, they would provide more of a baffle against the energy that these waves provide, and that could lead to erosion. Now, one thing also that's worth keeping in mind is look at how big this bay is and how much open water is in this bay. This bay, the size of this bay has been increasing over the past century, and Wilson and Allison, when they were at Tulane, had put out a paper showing that this widening of the bay leads to a larger sort of feedback effect. And what Carol Wilson and Meade Allison had noted was as the bays increase in size, you increase the wave action, you increase the fetch, you basically get a positive feedback loop that accelerates marsh loss. And this is part of that story. We've got a very wide open bay. We've got waves crashing on the marsh, and now we have fewer plants, at least at that particular spot, to buffer the energy. Okay, so the plant, if we have plants at the edge of the marsh, they're going to break down those waves, and they'll probably break down those waves right at the front of the marsh. We don't have plants at the edge of that marsh anymore, so the waves can crash with more ferocity. The waves can propagate a little bit further inland. You can watch the waves over there, and you can see them actually kind of running across the marsh a little bit. That run-up would have been stopped or slowed down if there were more plants there.
And why does it matter that the waves are there? What's that going to do to the marsh?
Waves can transport sediment. They basically bring in a lot of energy that can either bust up the marsh sediment and then take the sediment away. And so that transport of sediment, the lifting, removal of sediment and transporting it somewhere else is what we refer to as erosion.
And how has the oil contributed in this case? I mean, there's a real direct example of actual potential marsh loss.
That is an example of marsh loss. Yes, that it could be a direct example of marsh loss as a result of that plant die-off.
Unless the plants
yes, I mean, that's the thing. Unless the plants come back, now it's a pretty wavy day. How much does that marsh loss that's right there compare to the marsh loss that would have occurred here because it's a windy day? And I think that